students, welcome to Wisdom Academy YouTube channel. I am Nilesh and I am going to teach you physics for this 9th standard. So, your perception about physics till 8th standard would be different. I hope that most students think science as a theory subject. They will think in science, we will study about theories and you will write essays in the examination, you will come back, you will get some marks. But that does not go along with in 9th standard. So, in 9th, physics becomes numerical type. So, here we will have 5 chapters and starts from motion. You will have motion, then you will have force and laws of motion, then you will have work, energy and power, then you will have gravitation, and then you will have sound. So, except sound, all the other 4 units will be completely numerical based units. So, you should start now solving mathematics in physics. So, until now physics for you also would be some kind of theories about light, about reflection, about waves, about breeze, land breeze, sea breeze, solar system, but now it is not like that. Now you will learn about how things are happening in real life and how to calculate the values out of it. Like in the first chapter, you learn about motion, you will learn about what is distance, displacement, speed, velocity, you will learn about equations of motion. In second chapter, you will learn about what a force is, balanced force, unbalanced force. You will learn about what are the laws of motion. Newton gave laws of motion. You will learn about all the 3 laws of motion. You will learn also about momentum and problems based upon momentum. In third chapter, you will learn about work, energy and power. So, work in real life is different from work in physics. So, what is work and how to find energy, potential energy, kinetic energy and so on. You will learn about power, that is work done per unit time. So, all these things will come in the third chapter of physics. Fourth chapter would be gravitation, where you will learn about Newton's law of gravitation, and you will learn about what is acceleration due to gravity. You will learn about the satellites, you will learn about the Kepler's laws, and a lot of numericals will again come in this chapter. And the last chapter of physics will be sound, where you learn about what the sound waves are and what are the different properties of sound waves. You will learn about echo and reverberation. You will also learn about infrasonic and ultrasonic sound waves. So, all these 5 chapters, once again I am saying you, it will be numerical based chapters. So, what I expect from you is to be very thorough, be very attentive. Right from day one, I want you to be sincere. Only if you are sincere, you will be able to do well in your 9th physics. Otherwise, after 3-4 months, you will start feeling 9th science is tough, it is not easy. If you don't want to feel that, and if you want to be interested throughout the 9th, you must start solving questions right from day one. Next thing is, whatever you are learning in 9th physics will again repeat in 11th with a higher level. Same chapters, we will have motion, we will have laws of motion, we will have gravitation, we will have work, energy and power, we will have waves. All these chapters, if you don't believe me, go and check 11th standard book. All these chapters will once again repeat in 11th standard, and there it will be repeated thinking in mind that you have learned these chapters in your basic classes. So, those people who fail to learn these chapters properly now, they are going to suffer when they go to 11th also. If you learn it very beautifully, then I can assure you that you will be succeeding in your 11th class also. So, 9th physics is not only good for your 9th, it is also required for your 11th. Let us start the first chapter, motion. So, once again I want to say you that please take the notebook and pen and take the notes of whatever you are learning. So, motion, if I ask you what is motion, you will say it is movement. So, when anything is moving, it is said to be in motion. If anything is at rest, it is said to be at rest, if anything is not moving. So, generally we have this perception about motion, but is it so? Let me ask one question to you, and then you itself decide whether your perception on motion is right or not. So, I have one car is there. In this car, there are 2 people traveling. Okay, let the first person be Ram and the second person be Rahul. There is a third person standing here, he is Shyam. Now, when the car is moving in this direction, for Shyam, this car is in motion as well as Ram and Rahul are in motion. The reason is, even Ram and Rahul are getting moved. They are changing their position with respect to time. Like how the car is moving, even Ram and Rahul are moving with respect to Shyam. But if you see Ram, For him, Rahul is not moving because Ram is seeing Rahul, he is sitting in front of him, he is not moving. So Rahul, with respect to Shyam, he is at rest. So who is at rest? Rahul is in motion. Rahul is in motion with respect to Shyam. And Rahul is at rest with respect to Ram. Rahul is at rest. I hope you are understanding what I am trying to say. I will repeat once again. If you take Rahul as an example, then with respect to Shyam, Rahul is changing its position with respect to time. So Rahul is in motion. But with respect to Ram, Rahul remains at the same position. So Rahul is at rest. Now here your concept about motion becomes little complex. Like for someone the person is at rest, for someone the person is moving. Moreover, everything is happening on the planet Earth. If you are seeing from some other planet, we know that even Earth is also rotating. So all these things are rotating. I don't want to make it more complex for you, but I want to just say that motion is a relative term. You learned this in the higher classes. Motion is a relative term. So when I say relative term, it means that motion of one object we cannot be said just by one person. With different views, it will be different. So something at rest may be at rest with respect to one person, but may be at motion with respect to other person. Because if I am sitting and if I am sitting very idly in the room, I will be at rest. But if you consider me sitting on the earth and the earth itself is rotating, then actually I am in motion. Doesn't it true? You cannot, can you think about it? Exactly. So that is how the motion is. So with this example, I am going to just give a definition of motion, and please make a note of that motion, a condition where the object changes its position with respect to time. So if any object is changing its position with respect to time, then that object will be said to be in motion. Suppose if I am standing in front of you and next moment I am here, next moment I am here, and again I am here, then for you I am in motion because my position is changing with respect to time. So the easiest way to define motion is when the object changes its position with respect to time, the object is said to be in a state of motion. So you have studied about different types of motion in your junior classes, and you would have come to know what is rectilinear motion, what is circular motion, what is periodic motion, and all these things. I am not going to go in that level of classification, but I will classify motion with respect to other quantities, that is uniform motion and non-uniform motion. Uniform motion and non-uniform motion. So if I am right, you would have studied about this also junior classes. Anyhow, I will just rewind it and tell you what is that. So when I say uniform motion, it means that the object which is in motion is covering equal distances in equal intervals of time. And when I say non-uniform motion, it means that the object is covering unequal distances in equal intervals of time. Let me explain you what I am trying to say. So I have this timeline, and this is time which is 9 p.m. and this is 9:10 and this is 9:20 and this is 9:30. So I have taken half an hour of total span. I have divided this half an hour into 10 minutes, 9 to 9:10, 9 to 9:20, 9 to 9:30. So in this 10 minutes of span, if an object is covering 5 kilometer, again 5 kilometer and again 5 kilometer, then this object will be in a state of uniform motion because it is covering equal distances in this equal intervals of time. Interval of time here is 10 minutes, 10 minutes here, again 10 minutes here, again 10 minutes here. So body A, which is in a state of uniform motion, is covering equal distances in equal intervals of time. Suppose there is an object B, that this body in the first 10 minutes covered 10 kilometer, in the second 10 minutes covered only 2 kilometers, and the last 10 minutes covered 3 kilometers. So you can see in the first 10-minute interval moved very fast and covered only 10 kilometers. In the second 10 minute moved very slowly, moved only 2 kilometers, and in the third stretch covered 3 kilometers. This object is covering unequal distances in same equal intervals of time. This object B will be said to be in non-uniform motion, whereas object A was in a state of uniform motion. So I hope you would have understood what is the difference between uniform motion and non-uniform motion. Uniform motion is an object covering equal distances in equal intervals of time, and non-uniform motion is an object covering unequal distances in equal intervals of time. Let us learn the difference between distance and displacement. So, what is distance and what is displacement? To learn this, I will just take an example. Suppose there is A, this is your home, and there is place B, this is market. For going to market from home, there are a lot of roads. Some road goes like this, one road goes like this, one road goes like this, some road is there, it goes like this also. Right. Now, suppose I want to go from market from A to B. I have 4 roads. Someone is going on this road, goes like this, and reaches the market. Someone goes like this, someone goes straight like this, and someone goes like this. If you want to see, you will know that in all these 4 cases, the distance covered is different. It is not same. So, distance is the total path length covered. That means, if a person is going from here to here, here to here, and here to here, if you add these 3 values, that will be the total distance covered. If you add these 2 values, the distance covered if you are taking this path. If you find this whole length, that will be the distance of this path. But displacement is going from here to here in the shortest route. So, displacement is the shortest distance between 2 points. Shortest distance between 2 points. Remember, this 2 points, very important. So, starting point and ending point, what is the shortest distance? That is called as displacement. So, what will be the SI unit of distance? Obviously, distance will be meter, kilometer, centimeter. SI unit is meter. So, SI unit for distance is meters. Displacement, obviously meter, because it is a kind of distance only. So, here also SI unit is meter. So, you understood that distance is the total path length covered and displacement is the shortest path length. That means that if a person is starting from here, going and again coming back in the same point, distance covered will be addition of this thing plus this thing plus this thing plus this thing and this thing, but displacement will be 0, because if starting point and ending point becomes same, then the shortest distance between them is 0, isn't it? So, displacement, it can be even negative. I will see how it is negative. Suppose I am drawing a scale and it is origin 0, here it is 2, here it is 4, here it is minus 2, here it is minus 4, right? Suppose a person is going 2 units on the right side. So, he goes from here to here. Then from 2, he goes left for 6 meters. So, from here he started and ended here. And if I want to find what is the total displacement, so see the displacement started from here, ended here. So, this starting point, this ending point, what is this value? It is minus 4 units. So, in this case, the displacement is negative. So displacement can be positive, displacement can be negative, displacement can even be 0. But distance, it will always be positive. Remember this very important point, that distance can be only positive, whereas displacement can be negative, positive or even 0. One more thing I will tell you, something about scalar quantities and vector quantities. So scalar and vector, you will study about this in detail in the 11th standard, but remember that scalar quantities are those quantities which have only magnitude and no direction. So scalar quantities, quantities which have only magnitude and no direction are called as scalar quantities, whereas vector quantities are those quantities which have magnitude as well as direction. So if you see, distance has no fixed direction, it can be anywhere, but displacement has a fixed direction. Displacement can only be in this direction, it cannot be in this direction, it cannot be in this direction. So displacement is a vector quantity. So example I am writing for vector, it is displacement. Whereas example for scalar will be distance, because here there is no fixed direction, there is only magnitude. The students who are wondering what is the meaning of this word magnitude, it is nothing but how much quantity it is. If I am saying 40 centimeter, then that 40 is its magnitude, centimeter is the unit. If I say 100 kg, then 100 is the magnitude, kg is the unit. So magnitude means how much quantity that thing is having, that physical quantity is having, that is called as its magnitude. So you have understood the difference between distance and displacement, where distance is the total path covered, displacement is the shortest path between 2 points, starting point and ending point. Distance SI unit is meter, here also SI unit is meter. Distance is a scalar quantity, displacement is a vector quantity. Distance will always be positive, displacement will be positive, it can be negative, it can even be 0. Let us see one question. Find the distance and displacement of a cyclist moving around a circular park of radius 2 km if he takes 3 rounds of park. So there is a circular park like this and the radius of park is 2 km. They are saying that a particular cyclist which is taking 3 rounds of this park. So let us start from here, takes 1 round, then 2nd round and 3rd round. They are asking you to find what is the distance and what is the displacement of the cyclist. So let us see. We know that if the cyclist is taking 1 complete revolution around the park, then that will be the circumference of the park, isn't it? So in 1 round, what is the distance covered? Distance covered will be equal to 2 pi into r. R is 2 kilometers. Starting from here and completing 1 round here, it will be 4 pi kilometer. If in this question they are told to take 3 rounds, so what will happen in 3 rounds? In 3 rounds, the distance will be 3 times of this value, that is 3 into 4 pi, that is equal to 12 pi kilometer. So distance covered, answer is came as 12 pi kilometer. You can even put the value of pi as 3.14 or 22/7 and solve this and get the complete answer. What about a displacement? So just now I told that if starting point and ending point are same, displacement can even be 0. So here you see, started here, taken 1 round, taken 2nd round, taken 3rd round, ended exactly here. So what will be displacement? Displacement will be 0. So we understood in this question the distance is 12 pi kilometer and displacement is 0. This kind of questions are frequently asked in examination, where they will give the example of circular track and you have to find the distance covered and displacement. Be very careful in that. where is the starting point, where is the ending point. In the same question, if they would have told, in the same question, instead of 3 rounds, if they would have given 2.5 rounds, 2.5 rounds, then what will happen? See, you will start from here, take 1 round, take second round, and take 2.5. It will stop here. Then what will be the distance for 2.5? It will be to multiply by 2.5. So 10 pi kilometer. What will the displacement? Starting point is this, A. Ending point is this. This will be the displacement. And isn't it a diameter? Passing the center, it will be diameter. What is the diameter of 2 kilometers radius? Then displacement will be 4 kilometer. So for this case, the displacement answer will become as 4 kilometer. And distance is 10 pi kilometer. This kind of questions may be there. Be very, very careful and find the answer. So, questions can ask you in one more way. The question can be even asked like, if a person is going 2 kilometer in north direction, then he is taking a turn in the east direction and goes for another 2 kilometers. Then what is the distance covered and displacement covered? So, say in this case, starting point is this A, ending point in this B. Very conveniently you can say distance covered will be 2 plus 2, that is 4 kilometer. And displacement is shortest distance. So, it will be a straight line here. And isn't it a right angle triangle? So, by using Pythagoras theorem, this will be equal to 2 square plus 2 square, that is equal to root over 8. Root over 8, 2 root 2 kilometer. So, displacement will be 2 root 2 kilometer. Even this kind of questions are frequently asked, where you have to put your knowledge about Pythagoras theorem and find the answer. So, like this, there are lots and lots of questions given in the textbook itself. Please start solving it. We will share the assignment with you. You can even do questions from the assignment. And once again, I am trying to say that keep on practicing the question. The more you practice, the more strong you become. And there can be n number of, if you want, you can even frame your own question and you can do. So, please like the video, share with your friends, subscribe the channel, and for any doubts, please comment in the comment section. Thank you.